Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
This episode is part 2 of my interview with Charley Stevenson from Integrated Eco Strategy, and we continue our conversation about sustainable materials and healthy materials. We got into a little more detail about specific building products and approaches to selecting those products, and also prioritizing what systems to look at first, which has a bigger impact. So here's part 2 of my chat with Charley Stevenson. People that are not ready to, as you said, dive into LBC, what are some of the lightest lists? What are some of the lowest hanging fruit to really get the most bang for their buck, or their time and their effort to get more sustainable materials into their projects?
Sure. I have 2 thoughts in mind. If my practice had a mascot, it would be a ratchet.
Interesting.
And the notion is you do a little bit of work and you get a click. And then it's clicked. You've made a change and it's clicked. And then when you're ready, you can do a little bit more work and get another click. Sometimes it's really hard to get a click. Sometimes you get some really easy clicks. But that approach is half of the answer here. To think about places where in your practice, whatever it may be, you use the same product or product type again and again and again. I don't know of a building that doesn't have drywall. So
there you go.
Rather than think of this as a problem that needs to be solved all at once, we can just say, let's make sure we're using drywall we feel good about, because we always use it and we often use a lot of it. So we've reduced the hundreds of products that we're worried about to that single one, and then we ask the question, well, what's the right drywall to use? And if we can figure that out for a single family residence, and we can figure that out for a commercial retrofit, chances are we've covered 90% of the market. And then anybody who has that answer, any design team that's incorporated that and developed confidence in whatever that product may be, can simply make that their standard, or could make 3 good drywalls their standard and exclude from future work products about which they don't know as much. Click.
Makes sense.
That's done.
All
and
right.
It's on to the next segment.
What are the concerns with drywall?
Well, I'm trying to, a reason to focus on drywall, and I'm going to get to your answer in just a second, is that we use a lot of it. So,
right.
If you were to prioritize where changes in a material palette should take place, I think about what arrives by train car, what arrives by tractor trailer, what arrives in small cartons in the back of a pickup truck. So, drywall is not coming in the back of a pickup truck by and large. So there's a lot of it. When you're in a building, it presents a lot of surface area to occupants. So if it's good, it could be really good, and if it's bad, it could be really bad. So sort of starting with the inside skin that's presented to occupants and working out, deeper into wall assemblies is one approach. Thinking about volumes, procured is another way to prioritize. And then, back to thinking about mastics, wet applied products are different because the curing happens in the space. So whatever solvents or whatever chemical reaction makes it cure, that's happening live in the space that you care about. So, to the specific question, there are excellent drywalls, and there are, many commodity drywalls are fully disclosed are tested for off-gassing and pass with flying colors. So
Excellent.
that's, you can go to the major manufacturers, USG, National Gypsum, Certainteed, and you can ask and receive a red list free or red list compliant drywall.
Excellent.
Paints are another good example. First of all, there's often a lot of them in a project, and they're wet applied. So what they have for chemical activity can be significant. It's nice that this is, paints have been the subject of lead scrutiny for a couple of decades. So it's a pretty mature market, at least as far as volatile organic compounds are concerned. You
Yes.
can add the question of whether it's red list free. I think to a major manufacturer that we all know and has been prevalent in the industry for decades, if not a century. 8 years ago, a colleague of mine called to ask what was in their paint, and he kind of got a laugh back from that manufacturer to say, that's our secret recipe. There's no way we're telling you what's in that paint.
Oh man.
From his perspective, that made perfect sense.
Okay.
They now have a declare label for not one but many products, which means that over time, there's been comfort in disclosing, and there's a recognition on their part that they gain value by revealing their chemical constituents. So the declare label, for first steps, is a very effective way for project teams to identify places where there are simply good answers to the question, what product should I use? So the Declare product database is a pre-screened list of products. The screening is actually done by the International Living Future Institute. So products earn labels, and then you can search for them and simply see which products are pre-approved for use on an LBC project. And there's an awful lot within Division 9. So if you're looking for interior finishes, carpet, paint, floor finishes, ceilings, you can, I won't say entirely, but it's getting close to the point where you could simply pick products that pass muster just by looking for them in a pre-published list.
Nice. That has struck me as well, that finishes are, there's much more, I guess, awareness of healthy finishes.
Right.
I think maybe because you said it's, many of them are wet applied in space, and that's a big deal. But it's also, the homeowners going out to buy stuff for their home and really wanting to kind of, making much more personal decisions. I wonder how much that drives the manufacturers
Yes.
in that direction.
I think that's a lot. I think the fact that interiors have been the subject of lead credits for 20 years has driven that a lot.
Okay.
So it's a mature market. When I think about the reason to focus on material health or the health impacts of materials, it's a nested set of concerns. So at the core is just that issue. What impact will these material decisions have on occupant and building user health? So that's a very natural place. As you speak of a homeowner, please don't let me renovate my child's room to the detriment of my child's health.
Yep, there you go.
If we go out one layer, we ask the question of installer health. So, here's a place it makes sense that tradespeople would be concerned, and they're the ones who are working with these materials in the building at that period of maximum chemical activity. So that's the next layer. Shouldn't we ask the question, what products can I select for installation that won't have a negative impact on those people I'm hiring to install?
Yep.
Out the next layer is the manufacturing process. So an example here is neoprene. I have, it's not here at my desk, but before I got into this, I had a toddler and she wanted a colorful lunchbox, and it happened to be made of neoprene, which has all sorts of fantastic properties. She could spill in it and I could wash it out and it would dry and it was good to go. It is inert. I wouldn't mind her eating spilled applesauce out of it. But I'm awfully glad I don't live near or work in a neoprene factory. So turns out that the production of neoprene has terrible localized impacts. It's not a healthy, the act of producing neoprene produces some pernicious, in fact, immortal pernicious chemicals. So those impacts are felt by the workers in those factories, they're felt by fence line communities, and then once out in the wild, those chemicals persist. So it's not the case that we exclude neoprene from projects because it's harmful in the building, but there's no way to have made neoprene in a responsible way. So it makes sense, with that lens, to avoid consumption of neoprene, because necessarily that meant production of neoprene, which meant harm.
I was not aware of that. I'm going to have to rethink some duct liners and insulation now.
Right. Well, and this goes back to, here I am, you're asking how to do this simply, and I'm not making it simple. But, so that's maybe a 200 or a 300 level question, but it goes back to this idea of defining what success looks like. And once in my world, once I've seen that question of how do I keep occupants healthy that can actually be optimized, but it may be optimized at the expense of other people or other planetary systems. So this iterative process has us expand our scope of concern to the point where we're asking, how do we minimize harm across the entire system, not just for the building end users?
Right.
And that goes to, it goes to volume as well. There's not that much neoprene that goes into a typical building, but there's an awful lot of paint. So if resources are limited, as they always are, picking those areas where you can have the most impact, or flip that around, have the least impact with the least amount of work. That's to say, bring the most benefit with the least amount of work. You can get a few clicks on the ratchet there. And now you're thinking about
volume.
Yeah. And then you're thinking about little wins. So if you can think of where there's neoprene in a vibration isolation hanger, if everybody that specifies that asks their typical manufacturers whether it's available with an EPDM gasket, so a sort of benign rubber gasket instead, neoprene's lovely because it's resistant to absolutely everything. If you're not exposing those gaskets to oils, an EPDM gasket would have a comparable surface life. So sometimes the one-size-fits-all solution is very harmful. And if you could identify within your practice where a different gasket type does not risk exposure to chemicals that would cause it to degrade, then perfect. That one inquiry, that one substitution, ripples through a pretty wide swath of materials procurement. And you don't have to ask the question again.
Yeah. Yep. So how about, I definitely understand the point about volume. So drywall and paint and flooring, roofing, just the sheer mass, there's so much of it. And that's a reasonable place to start. Are there some kind of pernicious elements that are people don't know too much about, but they're relatively easy to avoid or choose better, make better choices?
So I would say often we can achieve results through deletion of products or expectations. So examples of that would be antimicrobial finishes or stain-resistant finishes. So or flame retardants. So
flame retardants is, fire alarms, as you said, was good. Flame retardants also sound pretty good.
So that's they do until you find out where they are and why they're there. So flame retardants, if you have an upholstered piece of furniture, chances are it has several pounds of known carcinogens soaked into the foam. And, the idea is we don't want this foam to catch on fire. I think in everybody's experience, before the foam can catch on fire, the fabric has to catch on fire, because you can't get the flame through the fabric without getting through the fabric.
That makes sense.
So, here's a case where the history is that, the notion, the history of flame retardants is people falling asleep on couches with lit cigarettes. And
yes.
So we want the fabric not to catch fire, and then we want the foam not to catch fire. Or rather, it's not a flame preventative, it's a flame retardant. We want it to burn slowly enough that there's time to get out of the building. There's time for the alarm to get off, and there's time to get out of the building. So, interestingly, those flame retardants don't prevent fire, they just slow it. But they do it in an awfully smoky, billowy black, toxic kind of way.
Jeez.
So it's
So it's toxic before it burns, and it's even more toxic when it burns.
Right. And if we just had something like a wool, or a natural fiber, flame retardant upholstery over it, we don't have to worry about. If we can slow the flame getting to the foam, we don't need to slow the flame in the foam. Now, this has been a terribly non-technical way of describing it, but it's an
no, it makes sense.
An example of a place where in many jurisdictions the flame retardants aren't actually required, and when you look at what those flame retardants provide, it's marginal safety even in a fire, at the expense of known health harm up until the unlikely event that there's a fire.
Right.
So in those trade-offs, we can try to solve the problem without introducing chemicals of concern. And that the same would be true of antimicrobials. Antimicrobial finishes are typically endocrine disruptors. So, and by design, they're things you're touching a lot. So the very presence of those endocrine disruptors, a classic example is on a baby changing station. Right, we'll take our most vulnerable, and we'll undress them on a plastic surface coated with endocrine disruptors. Right. Right. So put in those terms, maybe we could come up with a better plan. And the same would be true of stain retardant finishes. So these are typically Teflon derivatives, and they are impactful at every point in their life. They're terrible to produce. I happen to live in northwestern Massachusetts, and there are 4 towns near me, all of which have municipal water supplies contaminated by precursors to Teflon.
Man.
And yeah, there's no getting it back out of the groundwater. So, it's just across the board great to reduce Teflon production because that reduces this unavoidable ecological damage. Then, further down the line, it's these are present in effectively all life because these are immortal chemicals. What makes them stain resistant makes them resistant to everything. So both in terms of interaction with living systems, and then they're indestructible. So every Teflon molecule that we've made will remain a Teflon molecule through geologic time. So we don't know all of their consequences.
But it's the precursors. It's the precursors that have health implications. Is that correct?
Well, they are not. The precursors certainly have health implications. The use of Teflon compounds in certain applications also has health implications. So there's typically a Teflon coating or Teflon derivative coating in microwave popcorn. In the bag for the microwave popcorn.
Okay.
And there's I mean, it's how will I describe it? There's literature on people who eat more microwave popcorn than typical suffering health effects, not just from eating so much microwave popcorn, but from the Teflon compounds that they ingest with their microwave popcorn. You can kill certain sorts of birds by heating a Teflon pan too hot before you put food in it on the stove. And it's the canary in the coal mine in the sense that it's largely an immortal product, but it will interact under certain conditions, and that's revealing to us that many of these compounds are in fact biologically active, and therefore worth knowing about.
Yeah.
I keep slipping into these places where we're
right. I know. It's hard not to go down rabbit holes, but going back, big picture, focus on the quantity items like drywall and flooring and paint. Also, the coatings or the treatments, the fire, flame retardants, stain resistant materials, antimicrobial finishes. Right,
places where you can avoid through elimination rather than through substitution.
Right.
And this has potential health benefits. It also has potential embodied carbon benefits. How do you reduce the chemical load in the building? You reduce the volume and the number of products that you're bringing in. So lighter buildings with a smaller palette require, less research, and in many cases, less just sheer volume of product. So, places where you can have exposed structure, places where you're not putting a drop ceiling beneath another member, exposed mechanicals. Many of these are sort of modern design directions that teams would go anyway, but there happen to be ecological benefits to these on many levels as well.
Cool.
Yeah.
How about insulation? Blown bat over foam? You said that.
Yeah. So again, knowing that saying we're going to use cellulose insulation has other impacts as far as the other detail and the sort of construction quality having to play a bigger role. Natural insulation products can be seen as carbon sinks rather than carbon sources.
Define natural.
Yeah, so cellulose is sort of, in many ways, it's optimal on many levels. Many manufacturers are treating just with boron for both insect
Pest resistance
and flame resistance. So, inert chemistry. And then, as far as the source is concerned, you're taking a significant source of carbon in the world and you're putting it into a building for 50 or 100 or 200 years. That's a good, low-tech carbon sequestration strategy. Contrasted with spray foam or a rigid foam insulation product, which they're chemically complicated. Many of the blowing agents, though this is changing, many of the blowing agents are still powerful greenhouse gases, and often in the formulation there is a halogenated flame retardant to meet certain code requirements. There's middle ground in some of the wood fiber board insulation products. There are an increasing number of BAT products, both fiberglass and mineral wool, that are formaldehyde free. Cool. So, and again, these are not high weight, but typically high volume, large surface area products that go into a building. Another thing to think about is just stuff you touch every day. So I'm looking at it in the buildings. Where does your food land if you're going to pick it up and eat according to the 5-second rule? What's your doorknob finish? Just the things that you're physically in contact with. Those are places where it makes sense. In terms of bang for the buck, or health return for the effort. Those are places where it can make good sense to pay a little bit of attention. A doorknob is an example of something that is also repeated. Through a building, there might be one doorknob type purchased 20 or 30 or 50 times. So if you can, as opposed to the kitchen sink where there's only one kitchen sink.
Gotcha. I remember reading, I don't know, maybe it might have been a year ago, somebody doing some research where they replaced all the handrails and doorknobs with, I think it was copper, because copper has kind of innate antibacterial properties, as I understand it, and trying to ascertain if there was any reduction in, God, I forget what it was, communicable diseases or what. But I mean, stuff that you touch every day, some people would think, great place to have lots of antimicrobial finishes to prevent the bacteria spreading. But that's not where you're going for.
No, well, there's bronze is, many things have bronze or a chrome finish. Well, there isn't bronze without low levels of lead. So, if you look at a lot of hardware, you'll see that it comes with a California Prop 65 warning, which is to say this product contains known chemicals of concern. And when I see that Prop 65 warning, I'm usually, in the case of something metallic, I'm usually thinking that it contains trace amounts of lead. And so that's an example of a place where you can consciously move in the direction of not having. I'm looking at an antique doorknob here in my office, which I'm quite certain is bronze, and it's polished, which is to say that every day I use it and I clean it off a little bit with my hand, and then I go eat lunch. So, the purpose of this conversation is not to induce paranoia, but to sort of give frameworks for thinking about this, because there are many small steps which, taken incrementally, will move us in the direction of sensible solutions.
Excellent. One thing I like to ask, where are we going to go from here? If we talk about this again in 5 years, what do you think we'll be talking about?
That's a great question. I see in the 8 years that I've been working with healthier materials, I've seen night and day changes. Engagement from manufacturers who were completely really resistant, 3 and 5 and 6 years ago. New levels of awareness and engagement from the full spectrum of project types. This topic of healthier materials has had remarkable growth, and yet it's still the early days. So I think 5 years from now, we'll see much greater public disclosure. We'll see a much broader awareness of we take something, sorry, not a complete thought. We take BPA as an example. It had its moment in the spotlight and not favorable moment in the spotlight a few years ago. That's an example of the kind of market change that can happen when there's a lot of broad scrutiny on a particular product. The problem that can create, and we haven't touched on it, so I'm glad we are here, is what's known in the industry as regrettable substitution. So
yes.
If you have a water bottle that says it's BPA free, chances are it's chemically very similar to a water bottle that contains BPA. It might just contain BPS, which is to say it is literally BPA free, but it contains a different bisphenol compound, which is chemically similar to BPA. And in many cases, what this means is that, people use the term whack-a-mole, that we're sort of, we say, we identify this problem, BPA, we push it out of the system, and we replace it with a closely related chemical compound which hasn't yet been tested, which is to say it hasn't yet been implicated in studies of hormonal disruption, but there's an excellent chance that it will be. So, we want to be very careful that we're taking a class-based approach to this rather than an individual compound by compound approach, so that, the notion is not to eliminate BPA, but the notion is to reduce any BPX compound.
Okay.
So I think, moving from and there's been tremendous advancement in this discussion at the industry level. I think thought leaders like Healthy Building Network and the Health Product Declaration Collaborative, 6classes.org. There are a lot of unbelievably smart not-for-profit groups making tremendous strides here, and really what will continue to tip it is engagement by a growing number of practitioners and building owners, making this, even at the simplest level, a requirement for their projects, because indeed it's those market forces that bring about the most rapid and permanent change. So we just want to make sure that we're asking the right questions so that we get the right outcomes, not just elimination of single compounds, but reduction and elimination of whole families of chemicals of concern.
And continuing the trend of more and more engagement and more demand on manufacturers.
Right. Well, I think manufacturers are absolutely partners in this, and from a risk mitigation standpoint, they have the most to gain. They stake their reputations on the quality of their products, and none of them want to be implicated in long-term health impacts. So there's great alignment around this, and it's really a matter of raising the consciousness among all sectors of, I'm saying the building industry, but this entire conversation could port over to home electronics, it could port over to clothing, it could port over to personal care products. All of these same factors are at play. And I think as we have a common language, a common set of goals, and a common set of tools, we're poised for rapid transformation. And really, it's new chemical compounds that we need, because no one wants formaldehyde, no one wants carcinogens. They do want strong glues. So how do we achieve strong glue without the harmful side effects?
Excellent. Makes sense, and it's an optimistic note to end on. I think that we're moving in the right direction.
Oh, we absolutely, and I think we're constantly talking here at the office. We don't need breakthroughs. We want little clicks. We want incremental change, and the more people we have exerting this pressure, the more the market will move in the direction that makes sense. So we're fortunate to have powerful, brilliant thought leaders that can point us in a rational direction, and then we can, in small ways but in constant ways, exert these forces and help move the market.
And where can people find out more about you and your work?
We've launched a new website that's called materiallybetter.com.
All right. Awesome. Thank you very much, Charley.
This is a pleasure. It's fun to talk about. I'm grateful for your time and attention, and I look forward to continuing this conversation.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.